Now, the data type we're going to focus on today is called the double data type. And you may hear me incorrectly sometimes refer to this as a floating point data type. More to come on that in a minute. But this double data type is a built-in data type that holds as its values numbers with a decimal point. For example, things like 3.14, 1.5, or even negative 2.0. When we talk about an instance or an example of this data type, we'll be talking about a double, or in the incorrect version, we'd be calling a single object of a floating point data type a float. The operations that come along with this double data type are the usual arithmetic ones: addition, subtraction, multiplication, and division. To talk a little bit more about floats versus doubles, this is something of an antiquated point. Both floats and doubles are data types for holding numbers with decimal points inside of C++. The only difference is how big of a storage locker we allow to store that decimal point. Floats were originally meant to hold smaller numbers within them, only allocating 32 bits of memory to hold the float value. Doubles were meant to hold up to 64 bits of memory, double what a floating point value could take on, hence the name. Now, the reason that this is a little bit antiquated is that back in the day when we were programming and we didn't have a lot of memory on our computer, if we knew in advance that the variable we were going to represent was only going to hold smaller numbers, we would declare that variable to be a float in order to save and use less memory. And in the situation where we had a data type that might take up a little bit more room within memory, we would allocate to a double. These days, it's not particularly important. We have plenty of memory on our computer, and we really could do without floats that have this restriction of not holding as large of numbers as a double. But historically, that's what's going on in the difference between a float and a double, just for a little bit of context. Next, let's talk about the syntax for declaring variables and assigning values to them, including reassigning values to variables. There are several different acceptable ways that you can declare and assign values to variables within C++. But for now, let's focus on the declaration syntax and assignment syntax separately. In order to declare a variable in C++, the syntax is to first declare the data type of the object, then add a space, and follow that with the name that you wish to give to the variable of that data type. And that's what's shown right here in our slides. We then later on a separate line, assign a value to the variable once it's been declared via variable name, followed by an equal sign, followed by the value that we wish to assign to the variable name. And of course, we have our semicolons at the end of each line of code to indicate that we're done with those individual sentences. While the syntax I just described separates on two different lines of code the declaration of a variable of a particular data type from the assignment of an initial value to that variable name, we can actually combine those two steps into a single line of code with the syntax shown below. First, we list the data type of the variable. We then have a space and name the variable appropriately, followed by an equal sign, and ultimately the value that we wish to assign to the variable with our semicolon. Now I'll circle back to this point later, but I've been very careful with this equal sign. In a computer science environment, it's much more appropriate to see that mathematical equal sign and think of it like the word is assigned the value of. So the way that I might read out loud something in code that looked like this would be the variable name is assigned the value of value, rather than variable name equals value. You can run into problems with thinking that way. And so I'd like you to get in the habit of seeing that equal sign in a computer science setting and thinking of the word is assigned the value of. And we'll discuss this more with some examples. So let's return to Visual Studio and practice declaring variables called x and y that take on the values of 3 and 2, respectively. In order to first declare our variable x that is of the double data type, because we wish to consider the decimal points 3.0, we could type double x and end with our semicolon. This declares a variable named x that we can later reference with that name. I'll even go ahead and add a comment to my code, and comments within our code start with 2 forward slashes. You can see that the color changes, and this indicates that I can now just type an English sentence and it will be entirely ignored by the compiler when we run it. All right, this line of code declares the variable named x. And similarly, we can declare a variable named y. Next, let's assign values to x and y. With our syntax, variable name is assigned the value of 3.0. That's assigning a value of 3.0 to the variable named x. And similarly, y is assigned a value of 2.0. We could now replicate exactly what is on line 11 of our program using variable names and operations on doubles as follows. Print to the screen x divided by y and end the line. When we run our code, we'll see our same 3 outputs from before, 3/2, 1, and 1.5, followed with an additional printing to the screen of a value of 1.5 because line 22 of our code is exactly equivalent to line 11, just done using variables of the double type. Now, as I indicated previously, there are a handful of variations in the ways that we can do things. One variation is to declare both of our doubles, x and y, in just one line of code. And in order to do that, I can simply eliminate line 15. Rather than eliminate it for now, I'll just comment it out. Now this line 15, which is written in green, coming after those 2 forward slashes, will not actually be executed by the compiler. It now exists as a comment, just an easier way than deleting some code. So if you ever want to go back to it, it's still there for you. In this variation, we can declare variables x and y together because they are both of the double type in just one line of code, making things a little bit shorter and easier to read. In order to verify that this code is still syntactically correct and produces the same output, we just run our code again. Voila! The other variation that we discussed explicitly in the video is where we both declare and assign values to our variables in a single line of code. In order to do that, I'm going to now undo what I did previously, which is comment out line 15. I'll eliminate the declaration of y in the same line 14 as we had done previously. And now I will comment out where we assigned values in lines 18 and 19 to x and y, because I can simply do that in lines 14 and 15 by adding that equal sign along with the value we wish to assign immediately. Again, we recompile our code to make sure we're always getting the same answer when we do this, verifying that things are the same, and they are. My personal style preference is for declaring and assigning a value in the same line whenever possible.